So if we keep this property till the end, we can easily solve this problem. There are only two critical concepts. Okay, both cases successful, and let's submit this code and see our luck. So what is the calculation you can do here? It will be 2 plus 3 into 2. So this 2 is from column and this 2 is from row. Hello friends, today we are going to solve problem number 37 of Leetcode, Sudoku solver. So the input will be a Sudoku puzzle and then we have to solve that puzzle filling the empty blanks. So it is a typical Sudoku puzzle. So each digit 1 to 9 must occur only once in each row. So each digit 1 to 9 must occur only one in each column. And similarly, each digit 1 to 9 must occur only once in 3 by 3 sub boxes grid. Here they are going to use dot to represent an empty cell. So the input is going to be something like array of arrays. It is going to be a list of list, and every element here, every cell is going to be like a character. If it is non-empty, it is going to be a digit as a character or as a string, or if it is empty, it is going to be simply dot. And we have to fill the dots with the proper appropriate values, and then we have to return it back. And actually they are not expecting us to return anything. We just need to fill the input data in place. And these are the constraints. Row length is going to be 9, so it is always going to be a 9 by 9 matrix. Board I of j is going to be either a digit or a dot. It is guaranteed that input board has only one solution. It is something we can take advantage of. So we will not have any situation where we may go out of there is no solution for an input. At the same time, there will not be not more than one solution. So the only solution which we have to find and return. And topics. This problem falls under arrays, hash table, backtracking and matrix. We are not going to use hash table, instead we are going to use set. And yes, we are going to use backtracking using recursion. Consider this example matrix. It is an augmented version of the input matrix which is given in the problem. So we have augmented, for that we can able to learn it very faster. So what we are going to do is, we are going to find the next empty cell. We will traverse from left to right. We will find the next empty cell. And then we will try to fill this using a valid number. So what can be a valid number for this particular position? For every cell the valid number is between 1 to 9, and then we have to check it is not present in the row, not present in the column, and not present in the box. So let's start with 1, and 1 is not in the column, 1 is not in the row, 1 is not in the box. So I think we can put 1 here. So let's place 1 here. So once we fill with the valid number, like we don't know whether it is going to be the final value or not, but for now we can consider this as the final value, and then we can move forward. Now we are going to do the same operation repeatedly. That's why the recursion is going to come into play. We'll go to the next empty cell, and then we will try to fill this with the valid option. Again, start from 1, it is already there in the row, so we cannot use 1. Let's go to 2 is not there in the row, 2 is not there in the column, 2 is not there in the box also. So 2 is a good candidate for this particular cell. So let's fill this using 2. Now same operation, repetition. We are going to do this in recursively. So go to the next empty cell. Next empty cell is here. What are the options we can consider here? We'll start with 1. Can we pass 1? Because we cannot put, because 1 is already here, so we cannot place it here. Then can we put 2? 2 is already here, we cannot put it here. Next, go to 3. 3 also we cannot use because 3 is already here. Let's try with 4. 4 is here, we cannot use. 5 is here, so we have to go with 6. And let's try, can we place 6 here? 6 is in the column, it is coming here, 6 is here, so we cannot put 6 also. So going to the 7 is here, we cannot place 7 here. 8 is already there in the row, and 9 is already in the row. So all the possible values 1 to 9 are all exhausted. So this is a critical case. When we cannot able to put any value into an empty cell, what does it mean? We cannot say it is unsolvable. We have to come back to the previous cell. And we have to put the next possible value in that cell. That's why it is called backtracking. So we are going forward with an assumption that these are all correct values, but when we hit a roadblock, when we get a hard roadblock, we will come back and update this value. So in this case, what we are going to do is we will come back, we will remove 2 because if we place 2 here, we cannot put any value here. So it cannot be solvable. So let's see what else we can place here. Can you place 3? 3 is already there, 4 already there, 5 already there, 6. Okay, 6 is not there in the column, 6 is not there in the row, and 6 is not there in the box as well. So it means we can put 6 here safely. Okay, now moving forward, next empty cell is here. Again we are going to start with 1. Can you place 1? No, 1 is here. 2. 2 is not there in the row. 2 is not there in the column. 2 is not there in this box. So we can place 2 here. So previously when we kept 2 at this place, we could not able to fill anything here. But now we came back, backtracked and then updated this value. Now we could able to place a value here. Now what are we going to do? We are going to move forward, go to the next empty cell, probably this one. We will find the next possible value for this one. For this one it is not going to be like 1 we cannot place because 1 is there in the box. And can we place 2? 2 is not there in the row, 2 is not there in the column, 2 is not there in the box as well. So we can probably put 2 here. So like this we are going to keep moving forward. We are going to take an empty cell and we are going to try to place any possible value without breaking the rule. Once we can able to place a value there, we go to the next empty cell. Suppose we cannot put any value in that empty cell, we are going to come back. We will come back to the previously filled cell and then we will change that value to the next possible value for that cell. So this is called backtracking here, and we are going to keep doing until every cell in this particular matrix gets filled. When the last cell gets filled and there is no more empty cell to get filled, we can clearly say that the puzzle has been solved. At that time we can simply return the given input itself. So the critical things to remember here is whenever we fill a value here, next time whenever we are going to check a value for next empty cell, we should include this value in the comparison. So when we update a cell, we have to update the row check also, the column check also, and the box check also. So we are going to create sets. We are going to create 9 set for every row, and which is going to have all the filled values in that row, and we are going to have 9 sets for every column. Similarly, we are going to have 9 set for every 3 by 3 sub matrix, sub box here. So we will be having total 27 sets, and every time we are going to update a value in a cell, we are going to update those sets also, because we need those sets to be updated to actually get a value for the next cell. Also, when we backtrack and come back and update a cell, we have to update those sets also. So if we keep this property till the end, we can easily solve this problem. There are only 2 critical concepts. These sets should be updated every time the value gets modified. At the same time, we should be able to recursively do the backtracking. We have to update a value. If it is not, come back and modify the value. That's all the problem is. Let's go for the implementation. The input is given in the variable board. Let's use it as, let's save this as a class variable. Let's put it in self dot, because we are going to use this in other helper functions. And let's initialize our checks first. We will set checks. We will call them in a moment. So now checks are set. We are going to recursively call solve puzzle, solve Sudoku to solve this one. And when we are going to solve this one, we are going to pass from where we have to continue. So until which point we know it is already solved. So first time it is going to be called with 0 0 self dot solve. We are passing 0 0. So when I am going to expand the function, it is going to make more sense for you. By the time when this function gets completed, we will have the board input board value will be filled with appropriate value. That is expectation. Let's go and implement the helper functions. So when I am implementing this solve Sudoku function, you will understand it better. Let's implement the set checks first. It's not going to take any parameters. So here we are going to initialize the checks. Row check is going to be a array of, it's not array, it's a dictionary of set. So I equal to set for I in range of 9. Similarly, we need 9 more sets for column and box. Column is this and box is same. So we just copy pasted, and we are going to traverse the input board, and then we are going to set appropriate values in those sets, check values. So let's traverse this for I in range of 9. Similarly for j in range of 9. So consider this is the row and this is the column. We'll take the character at the current position in the board. So C is going to be self.board of I of j. Now if C is dot, it is an empty cell, we can simply continue. If C equal to dot, otherwise we have to update row, column and box. So we can simply update row of I dot add C. Similarly call dot I dot add C. But how do we know which box? Like box index has to be calculated, right? So we have mathematical formula for that. So actually what we have to do is all these 9 cells should come under box 0. All these cells should come under box 1. These 9 cells should come under box 2. Similarly 4, 5, 6, 7, 8, 9. The range for the box 0 is going to be 0, 0, 2. This is going to be 2, 2. So 0, 0, 2, 2, 2 has to fall under box number 0. Similarly, this is going to be 0, 2, 2. So this one is 2, 4, not 4, 5. So 0, 2, 2, 2, 5 should fall under box number 1. So similarly, this one to this one, this is going to be 0, 5, 6, 7, not 6. So this is going to be 2, 8. So 0, 6 to 2, 8. This should fall under box number 3. If you see, using the I value and j value, this I value and j value range. So using this we can come to some formula. Let's try to find which row, like let's say the box is going to be 3 cross 3. Like we have box 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's put them in a column row combination. Let's put it like a matrix. So if we can able to identify which column and which row this box falls, we can consider. For example, if the row is falling under second column and first row, we can say it is box number 5. Similarly, if we can able to determine the column is going to be first column and row is going to be third row, we can say the box is going to be 7. So let's try to segment the columns into 3 and rows into 3. So column range is going to be 0 to 8. So this is column, and if you do call floor division 3, you will get which segment it is going to fall. So 0 to 2, it is going to fall under 0. 3 to 5 is going to fall under 1, and 6 to 8 is going to fall under 2. So we can see if the column value is, or the j value is between 0 to 3, we are going to map that to 0. It is going to come under this particular column. That's what we want, right? If it is falling under 3 to 5, so this is 3 to 5 column 3, 4, 5, and this should be mapped to first column here. So we can able to map it here. So the operation for identifying which column the box falls into, we need to do floor division of column value. So j floor division of 3 will tell which column this box is going to fall under. The similarly we can do for row also. So for row, that is again same. Row range is going to be 0 to 8 and 0 to 2 has to be in 0, 3 to 5 has to be in 1 and 6 to 8 has to be in 2. So the operation is going to be again row floor division 3. Hope it makes sense. So by doing call value j floor division 3, we can get which column the box is going to fall under, and by doing row floor division 3, we can identify which row it is going to fall under. Then we need to come to the actual value. We know it is going to fall under second column and second row, and we have to come to the value 8. So what can be the value? Like now, let's put this one. Call we determine to 2. This is like column of a row of the box data, and row is 2. So when row is 2, column is 2, we need to get the actual value of 8. So what is the calculation we can do here? It will be 2 plus 3 into 2. So this 2 is from column and this 2 is from row. So if you do that, 2 plus 6 equal to 8. So the formula to find the box index is call value floor division 3 plus 3 times of row value floor division 3. So you check this formula with any row and column in the 3 by 3 matrix, you will able to identify, you will able to come up to the correct box value, box index. We are going to use this formula. And in this program, there will be multiple occasions we have to calculate the box index. So let's write it as an independent function. So def get box, or we'll simply call box index. Box index of when passed with I and j, it is going to calculate the box index and return. So return j floor division 3 plus 3 times I floor division 3. Just verify this with other indexes, then you will come to know that this formula is correct. So now we got the box index, so we can simply say box of box index, we need to call self dot box index of I comma j, we can add c. So initially set the checks, so which we are going to use it for now. Now we have to implement the solve Sudoku function. Let's do that. Def solve, and it is going to take self comma initial value of I comma j. Let's always use I and j. Let's consider I is for row and j is for column. We passed 0 and 0 as index, but 0 0 may not be the empty cell. So we need to get the first empty cell. So we are going to get first empty cell by self dot get next empty cell passing I comma j. We will implement this. Just think that this function is going to return the next empty value, and when we got the next empty value, we are going to get what is the possible value for that particular cell. So that we need to do the calculation. We have to check with the row check, column check and box check. Whichever number is suitable for that cell, we are going to put it there. So for that we are going to have a function. So let's call the value as next value. Next value is going to be get next val for the row, for the column, and the previous next value was 0. So we will see why we are passing 0 here. I will explain you in a moment. Now when we get some next value, so while next val is not none, so we will say we will make this function return none when it cannot able to put any value there. So if you remember in the example, for the third cell we tried to put 6, but we could not able to put 6. We could not able to find any number to fill in that place. So in those conditions we will make sure this function is going to return none. If it is not none, then it means it is a valid value. Then let's put it into the board. But we are not going to directly assign that. We will call a function for that. Self dot set cell will pass I comma j comma next val. Why? Because whenever we update the cell, we have to update the corresponding row check, column check and box check. Why? To keep that, replicate the code, we'll put it inside a function. So after filling that cell, we try to solve the rest of the Sudoku. So we are going to call the same function, solve Sudoku of, should be self.solve. We are going to pass I comma j plus 1 because I comma j just now we filled. So anyway, the next cell we are going to start from there. So we are starting from the next cell. And how do we know it is solvable or not? We should make sure this function returns false when it cannot able to solve that Sudoku. So let's check that if it is true. If it returns true, we are also going to return true. It's a recursive true. You have to be a little bit calm to understand. Let me implement the function and then you will understand it better. Otherwise, if it is not true, it means we cannot able to solve the Sudoku by placing next value at position ing. Now we have to consider some other value for the position ing. So we are going to again call this particular function here. But this time instead of passing 0, we are going to pass next val. So I told you, right, I'll come back to this moment, because first time when we are about to fill that position, we have to consider every number from 1 to 9. But when we identified, like we filled 2 first and then we are going to backtracking, 2 was a wrong number, we should not again start from 1, right? So we should start from 3 to 9. Among the values 3 to 9, we have to pick the next possible value. If any number is not possible from 3 to 9, we have to go back, we have to move back, we have to go to the backtracking. So we will get next value here. So this should return the next value. So if you consider this example only, so let's remove all the filled values. So first time we are going to call that solve Sudoku function using index 0, 0, 0, 0 is being called. So next empty cell is being collected. It is going to be 0, 2 and we got 0, 2 index. To fill this particular value, we are going to call get next value. Yes, we are going to call get next val and index is going to be 0, 2. First time we are going to call this with 0. Okay, so we got some value. Okay, first time we can fill with 1, we are filling it with 1. So solve Sudoku got a value for 0, 2. Then so next value is non-empty, it is setting the cell. Then it is calling solve Sudoku of I comma j plus 1. I was 0 and j was 2. So we are going to call 0, 2 plus 1. Now it is going to pass this cell and next empty cell is this one. So we need to get a possible value for this one. So for this cell, we are again going to call get next val of 0, 3. This is the index of this particular cell. And the first time when we are going to call, the next value is going to be 0. So when the next value is 0, we are going to consider every number between 1 to 9. First we are taking, okay, 1 is already there, we cannot use. Then you go with 2. 2 is not there in the row, 2 is not there in the column, 2 is not there in the cell. So we are filling this place with 2. So remember, you have to mark this one. It is initially called with 0 and it has returned 2 here. And that 2 has been stored at this point here. You should remember this. Okay, now after filling this, so the solve Sudoku function is going to set the value. It set the value here. 2 is filled at 0 and 3. Then it is again calling solve Sudoku of 0 plus. So it was initially 0, 3. This is 0, 3. It is going to call 0, 4. 0, 4 is not an empty. It is already 7 is there. So we are going to call get next empty cell. So that is going to give us this particular cell, which is nothing but 0, 5. So now we are going to call, I'll put it here, get next val of 0, 5 and 0. For this particular cell, we are going to consider 1. 1 is not possible because 1 is here. Considering 2, not possible because 2 is here. Considering 3, not possible because 3 is here. Considering 4, not possible, 4 is here. 5, not possible, 5 is here. 6 is the only option, but 6 is here in this particular column. So 6 also not possible. 7 already there in row. 8 in the row. 9 in the row. So 7, 8, 9, nothing is possible. In the range of 1 to 9, nothing is possible for this particular cell. So now we are backtracking to this cell. When we are coming back, we have already considered 2. So we know that value we have considered 2. This time this function returned none. So we are going back. When we are going back, we are again going to call. When we are backtracked here, we come to know that 2 is not a valid option. So we should not fill this place again with 2. So we are going to call get next val for the index 0 and 3, and the next value is 2. So this is going to, so the third argument is going to be the previous next value which we have already considered. So when we pass this one to this function will not consider any number before this. So it will not consider 1 to 9 for this cell. Instead it will consider 3 to 9. So the check will start from 3, not possible, it is here. 4, it is here, not possible. 5, not possible because it is here. And 6 is possible. It is not there in the row, not there in the column, not there in the box. So this function is going to return us, the return value is going to be 6. So we will rewrite this particular cell with 6. This is the purpose of the third argument for the get next value. So when the value is 0, we are going to consider every number from 1 to 9 for that particular cell. If it is a non-zero, we are not going to consider any number before that including that number, and we are going to consider only numbers above that until 9. So this you have to understand very clearly. We will see the implementation. So next value is again going to be set here, and we are going to continue solving the problem. And when while next value is not true, it means if this returns none, so we don't able to find any possible value for this particular cell, we are going to return false. And when we are actually changing the next value here, we are going to set a new value here, right? So we identified this particular function is not possible and this value is not a good value. We have to remove it from the board. So for that we are going to call a function self dot clear cell I comma j comma next val. So we are going to remove this value from this particular position. Alongside we are going to update the row check, column check and box check. Now let's implement the helper functions. First set cell I j comma val self dot board of I of j equal to val. At the same time checks self dot row of I add val. Similarly for column, similarly for the box, that's all. We have to do the reverse for the clear cell. We are going to set it to dot because dot represents an empty character, and we have to do the same operation here, but instead of add we have to call remove. So simply copy and paste here and replace add with remove. Copy, paste. Okay, that's a typo. This should be J, but it is set as I. Yeah, we get into problem with these kind of smaller typos. Okay, so now just implement the get next empty cell. We have to implement this function. It is pending the last function. So we are going to search in the board from this position to find the next empty cell. Found empty cell initially set to false for I in I less than 9 while j less than 9. We'll see if self dot board of I comma j equal to empty cell. We can break out from here and we can set found. We don't need to break out, we can simply return I comma j. Otherwise we have to increment j. If j is exhausting to 9, we have to increment I 1 and j should be reset to 0. If this is also over, we have to return I comma j. So we are going to have another check here. If I greater than or equal to 9, we can return true. It means we have already filled all the cells. Implemented all the helper function. Let's run this code with example test cases. Okay, there's an invalid syntax. Where? Inside this probably. Okay, this is not equal to, it is going to be colon. Okay, let's rerun this. Solution object has no attribute get next val. So we had that right. Next empty cell. Okay, get next val is not implemented yet. We have to implement that here first. So let's have one class variable for representing all the characters. So unfortunately in the given problem they didn't give the cell value as numbers. It is all characters or strings. So we will mimic them here. Char seek is going to be 0. Actually I'm going to convert that into integer and use that as an index. That's why I started using 0. But why I'm doing this, it is easy for comparison. Like every value in the board we are going to take and compare with the check. Instead of converting that every time into integer, this method is going to be a little bit easier for us. So let's implement get next value. I comma j comma previous val. So let's just convert the previous value into integer. Index in the char sequence is int of value, and while index less than 10, so it has to be up to 9. Let's take the corresponding character from the char sequence. So c equal to char seq, which we have initially created, of index, which we have already considered. The previous value is already considered. Let's start with +1. So initially it is going to be 0. We are not going to consider 0. We are going to consider from 1 to 9 only. So when it is 0 also, it is going to be 0 plus 1. Index starts from 1. If it is already considered value, we should not reconsider that. That's why the previous value +1 we are moving forward. So this +1 is always going to be correct. We got the character, and if c, we'll put it as a cumulative function, c not in self dot row of I, and c not in self dot call of j, and c not in self dot box index of I comma j. If the c value is not there in row also, column also, the 3 by 3 sub matrix also, we are going to return C as the next value to be filled in that cell. Otherwise, we are going to return none. It means we cannot able to fill this with any value. And if else case, we have to increment the index plus equal to 1. Okay, we implemented this particular function which was being complained previously. Let's run the test cases. Char sequence not defined. Okay, it is a class variable. It should be self.char sequence. It says solution object has no attribute row. Why it doesn't have a row? What did we kept? This is surprising. Okay, for some reason this is not a class value. Here we are initializing, but we are not initializing them as a class value. Self. So we'll just copy and paste it everywhere. We'll try now. Row is not defined again. Okay, it is going to be self.row. Oops. Self.row, self.column, self.box. Okay, good. We got one more typo. It will be J. I, comma J. Okay, let's run this code. Okay, both cases successful, and let's submit this code and see our luck. Nice, our solution got accepted. Hope you liked the video. Please don't forget to give a thumbs up and subscribe for the channel for more such videos. Thank you for watching.